Yeah, hello everyone. Johnny from DapuStor. Today I'm gonna talk about the Stream CSD, which is targeting for reducing the enterprise and data center SSD write amplification and improving the sustained performance. Several topics here. First, I will brief in the trend in the NAND industry and some content about the garbage collection and existing approaches to reduce the block interface tax. And then I will elaborate more about the technologies of enabling DapuStor Stream CSD and the design overview and the benefits of Stream CSD as well. Yeah, first let me ask you a question. So what do you think what's happening in the flash industry? Basically for the demand and supply status. So yeah, we have collected some data that the NAND vendors have lost over 24 billion in the NAND business. Of course, they have started to make money from this Q1, but unlikely to recover the losses by the end of 2024, probably by the end of 2025. So in other words, the whole NAND makers doesn't make any sense in maybe 4 years or 5 years. It's kind of a disaster. So that's why the NAND makers is kind of cutting the capex. That's the supply side. But everyone is talking about the data explosion era. So especially for the AI generic content. So there was a forecast that in 2028 it will be 384 zettabyte data will be produced. So that's very tremendous data need to be stored. So how to balance this supply and demand? So is there any problem will occur? We don't know, but should be some problems. So yeah, there is an inevitable issue in the flash industry because the NAND flash has some characteristic that the programming by page but erased by block. So there will be some valid page in the victim block. Then we need to migrate the page to the new block and then copy back. That's why we directly cause the write amplification and impact the SSD performance and lifespan. And the drive requires some OP. That's why we have wasting some spaces and endurance. So for that case, the entire industry is kind of figure out how to fund the optimization of a garbage collection process and reduce the write amplification. Existing approaches. On the left side is the traditional SSD, and you can see that on top of that there's applications. Different applications have different data, and the data will be transmitted to the OS corner and then transmitted to the SSD. But unfortunately, during the process of the FTL, the data will be the data from different applications will be mixed in the blocks. So that's why the garbage collection occurred. There are many solutions like ZNS or Open Channel or even FTP and etc. Solutions brought out, but there are many drawbacks. The major one is all of the solutions are host involvement. This kind of solution is not compatible with the current block interface software ecosystem. So that's why I think it's the major obstacle of widespread of the multi-streaming mechanism. So DapuStor is proposing a host transparent solution. So we have, let me emphasize this starting point of this Stream CSD. Usually, engineers want to figure out how the lifetime of the data. So, do we really need to find the lifetime to do the classroom or to do the streaming? The answer is no. Actually, from DapuStor's observation, we can do some content learning and do the host transparent multi-streaming. So we have found out that the channel entropy value and the compression ratio can be the representatives of the streaming ID to do the multi-streaming. So these slides, I will focus on the compression ratios. So the compression ratio can be universal or can be efficiency, can be low A. So let me check. Yeah, we have collected 18 plus 3 data sets from various domains. You can see that from the biology or security or advertising or AIGC, etc. So we have divided the data sets to 4K by pages. And we quantified the percentile of the compression or the distribution of the compression. We have found out that the pages from the same data set, the compression presents very convergent value, and it is very universal one. So from this chart, we can see that the compression ratio, it makes more differentiated by the compression ratios. You can do the streaming by this way, and it's very universal. So we also check the compression ratio and other entropy or TF-IDF methodologies. Of course, the traditional TF-IDF method is works very well for the text-based content, but it doesn't work well for the audio or video content you can see from the 15B or 15C data sets. But the compression ratio works very well, and you can see that the purity is very good. And on the other hand, SSD controller usually based on ARM CPU or RISC-V CPU, so the power, the CPU is not so powerful. So as previous presenter said that the software to do the compression or to do the classroom is not so efficient. So we have stimulated the efficiency. You can see that if we do the TF-IDF by software, the execution time is very long. It's not acceptable. But this CSD data is based on a hardware compressor, which is a basic design. So the access time is very, very good. It means from above, we can see that the compression ratio is very universal. It's very efficient, very the computational overhead is very low weight. So next one I will talk about the design overview of Stream CSD. Of course, there are many need to deal with, like the data, after the data was transmitted to the drive, we cannot, we need to avoid additional data movement or access in the memory buffer. So the compression engine should be in the right path to avoid any latency. And another very important step is we can use the compression ratio as the identification of streaming ID or classroom ID. Major benefits of streaming CSD. Of course, we have done many comparison between the streaming CSD and other counterparts, including single stream is a conventional SSD, and some other streaming methodology like auto stream or manual stream. We can see that the WAF, write time amplification factor, was very good, and in many data applications, including Microbench, or RocksDB, or MySQL, or SQLite. And the performance of streaming CSD also, much better than the single stream. So in the work, the stream CSD can achieve up to 63% reductions in WAF, and also offers the performance comparable to other host involvement methods. It's very impressive. Yeah, now AI is very hot. So what we can do for multimodal generative AI workloads, we have done additional experience. You can see that we have built a solid engineering sample prototype with ASIC, with a controller. It's a PCIe Gen 5x4. This ASIC has a hardware compressor. So we have compared the single stream and the stream CSD with the WAF and the copyback ratio. It showed that the WAF reduction maximum by 37%. So it's also very impressive. Okay, so the last part is benefits of DapuStor Stream CSD. DapuStor version 6 Stream CSD. As we discussed, that this kind of model is host transparent, and it's very efficient. It's very, how to say, computational, very lightweight. So to the users or to the customers, host transparent is very easy to use. No need to adjust any system, no modifications. It's very easy to use. And the sustained performance also improved. And yeah, there's another key advantage is you can extend the drive lifetime to maybe 5 to 8 years or maybe 10 years. Of course, it depends on the data patterns. And it will definitely reduce the TCO, the total cost of ownership. And to the industry, I think it's a groundbreaking method to address the garbage collection and right-time application factor issue. And it's a balance of the demand and the NAND supply. So yeah, that's all for the content. And actually, we have a booth. If you have interest, you can stop by booth 911. And we have a very comprehensive product portfolio, including PCIe Gen 5, OCP or FDP, and high cap QLC products to fulfill all your demands. Yeah, thanks for your attention.